Hi there, folks. This is your last set of videos for the whole year, which is super, super duper exciting, hopefully. This week I'm going to split this video into two parts. You're only learning about circles, but just know that in the past we've taught circles, parabolas, sideways parabolas are included in that, hyperbolas and ellipses. So we're actually going to cross off the parabola part. If you're curious about the other conic sections, feel free to look into it on your own time, but we're going to start by just a reminder of completing the square. So I'm actually going to have us go through the first one together. I'll have you try number 2, but I'll give you a little hint as to what to do to start it. So completing the square, super easy when you're solving. A little bit easier if you're trying to get an equation from it. So what we're going to do is, first of all, add the 7. Sweet. We did a little reminder of this when we did quadratics, but I'll just do it again. Then you have to add, b over 2 squared to both sides. That literally completes the square. It makes it a perfect square. So your b value in this case is 6. So we have to take 6 divided by 2 and square it. That gives us 9. So I have to add 9 here. I have to add 9 here. Okay. Then to complete the square, you literally turn this into a perfect square. So this is factorable, and it's a perfect square. So this is really x plus 3 times x plus 3, or x plus 3 squared, and that equals 16. Now, the nice thing is that you end up with something hopefully square rootable, because to then solve for x, I can square root both sides. Normally, I would say that this is going to be plus or minus, so I actually want to give both. When you're talking about circles, you're only going to need to worry about the positive because it's going to represent a radius, but for now, I'm going to have x plus 3 equals 4, and x plus 3 equals negative 4, and then you solve for both, right? Because the square root of 16 is positive and negative 4. So then you get x equals 1, and you get x equals negative 7. And normally you'd want to check both by plugging them back in, just so you know they do both work. So you're good to go. Number 2, I'll have you try in a second. But what I recommend doing first is actually dividing everything by the a value first, because you can't complete the square when you have a number greater than 1 there. So add the 2 like normal, and then I'll have you finish this in a second. Divide everything by 5, which makes our b value a little crazy looking, but I think most of us can deal with the fraction part here. So what happens is when you do b over 2, it's like you're doing 4/5. You don't have to worry about the negative, because if you square it, it's going to be positive anyway. If you divide that by 2, it's the same thing as multiplying by a half. So I just wanted to help you out there, and then square it. So add that number to both sides, see if you can factor what's left, pause the video, and when you're done, I'll have an answer. All right, guys, I'm bringing in basically part of the work so you can see how it's done if you didn't quite get the answer I'm going to get. Just a reminder that if you multiply 4/5 by a half, you get 2/5. Leaves things in terms of fractions, because it'll actually be easier for you to square root and get a normal answer. So you're adding 4/25 to both sides, because when you square the 2, square the 5, you get 4/25. So you have to add it to both sides. This side you need to get a common denominator, so multiply top and bottom by 5 here. So you get 10/25 plus 4/25, which is 14/25. And then for this one, a rule of thumb is also, which is kind of nice, if you factor something like that, first of all, notice the negative. Has to be negative here because it's subtraction. But if you can't think of things that multiply to 4/25 but add to negative 4/25, it's always going to be your b over 2 number, so it's 2/5. Same thing if you notice on the top one, it was your b over 2 value that factors. So that's always kind of a quick shortcut to help you with that. So then you square root both sides, leave again things in terms of radicals. So I would do plus or minus radical 14 over 5, because the square root of 25 is 5. and then add the 2/5. So you end up with 2/5 plus or minus radical 14 over 5, or you can write it as 2 plus or minus radical 14 all over 5. Either one works, but you should have fractions, not decimals. Thanks very much. All right, moving on. Okay, so guys, this is just a background into the circle, ellipse, parabola, and hyperbola piece here. The video that's on here, you actually cannot click on, so I posted it, so you should have actually already watched it. So I posted it as like a separate link. But what happens for a conic section, it's literally in the name. A conic is like a cone. Think of like an ice cream cone and then another ice cream cone, and they're attached at the base. Ice cream. A conic section is if you take a slice of that cone. So if you slice horizontally to either part and you turn it on its head, you get a circle. If you slice it diagonally, but you don't hit another part of the cone and you turn it sideways, it looks like an ellipse. If you slice it and you can't reach the other side, but you don't touch one of the edges, notice it's like cutting off a side. It looks like a parabola, either like this or like this. And then a hyperbola is like two parabolas. So it could either go vertically or horizontally. I'm kind of bummed we can't go through these ones because usually I do a project where you make a video and you see shapes in real life and it's really fun, but whatever. Can't do it. Okay, degenerate conics are basically, they're not degenerate people. They're inanimate objects. So if you cut a conic where it meets, you end up with a point, right? You're not actually cutting any figure. If you cut diagonally but you hug both sides, it actually ends up making a line, which is weird. And then if you hug it, like if you press a piece of paper up against the cone, like basically hugging it on its side, it creates two intersecting lines. So all of that has to do with basic conics. We're gonna go through one more thing today, and then the second video we'll do a lot more of the practice. All right, so circles, pretty basic. The nice thing is about the distance learning is this is the only conic shape that we're gonna go through. But just a reminder that this is the form, you guys learned this in geometry, very similar to a parabola. The only difference is that the ending number is your radius squared. So that's your radius, okay? And then h comma k is your center. And we'll go through how that works in a second. So, the point 1 comma 4 is on a circle whose center is -2 comma 3. So literally automatically I know my center is h comma k, so that means h equals -2, k equals -3, based off of the fact that your center is h comma k. It says write the standard form of the equation of the circle. So the difference is your textbook likes standard form as this. This is actually factored form in most textbooks. Usually standard form is like if you expanded that all out. We're always going to do factored form with these. So it's actually kind of nice because you don't need to do a whole lot of work once you plug in values. The difference with this question is I don't know the radius. If I knew the radius, I could just plug it in here, plug in the center, I'd be done, okay? But I need to actually calculate my radius. So what I like to do is use the distance formula, or what's very similar to the distance formula, but a little easier, is the Pythagorean theorem. I'm looking for my radius, but now I know between -2 and 1 is 3. Between -3 and 4 is 7. So then I can use Pythagorean theorem to solve for my radius. So again, you can, to find your radius, given a point in the center, you could use the distance formula or triangle. I think the triangle's faster. It's up to you. If you remember the distance formula, great. If you don't, it's x2 minus x1 squared plus y2 minus y1 squared, all square rooted, which literally is what we did, but with Pythagorean theorem. So anyway, x squared equals 7 squared plus 3 squared, which is really 49 plus 9, which is 58. Okay, and then you want to reduce the fraction a little bit, and that's going to give us our radius. So you're going to get the square root of 58. I don't need the negative here because, again, it's a radius, so you want to keep it as a positive. But this is really 29 divided by, or sorry, times 2. We'll see if anything else can go in, but I doubt it because you can't divide by 3. So that is all you can do to simplify that. Okay, that's your radius. Just so you know, R is another way to say that. Okay, so if I plug in those values, now I'm going to do this in a different color. I'm going to plug in what I know. So the formula is here again. Remember, you need variables if you're talking about an equation. So x minus h was -2, so it's minus -2. Eventually you'll simplify that a little bit. Y minus -3, because that's our h and our k. And then it's your radius squared. So the benefit of knowing that our radius is radical 58 is radical 58 is your radius, and you square it, so the radical is going to go away, which is so nice. So your equation ends up being x plus 2 squared plus y plus 3 squared equals 58. And I'm not going to make you expand that out, so you'd be done. All right, that's it for these first set of notes. The next set will come tomorrow.